Hi, welcome to Gravitational Fields Lesson 3C. We start by drawing the field lines for this strange mass floating in space. The secret for drawing these types of field lines, which is a question they can ask you, is to find the bits which are just sort of sticking out. And they're real easy because you're just going to be attracted to them straight away. So you're going to have field lines sort of coming in like this. Not a problem at all. Where it gets interesting is where we've got these valleys, because remember, a field line is the resultant force on a mass. So if you were a mass coming into this valley, as you got close, you'd actually be pulled left or right by the mass either side of you, which means whenever we've got field lines going into a valley, they tend to curve. So this one's all going to come down here and then curve in that way, and this one's going to come down here, curve in that way, leaving a little space with no field lines here, because of course you're going to be pulled either way, so there's not going to be a resultant force. Same thing here, we're curving in like that, and curving in like that, and then just sort of straight in like that. Bob's your uncle. So that's how you draw the field lines on a strange lamina. The reason I wanted to have this shape up here was so I could talk about a new idea, and that is the concept of an equipotential. An equipotential is a line that links together places which all have the same potential energy. The best way to think about this is if you've ever done orienteering or looked at a map, contour lines on a map on a hill show you areas which are all the same height and you can link them up. Equipotential is the same sort of thing. They're points, all of which have the same potential energy. So, if we were to draw an equipotential around this shape, all we'd have to do is draw something that was sort of equidistant from the mass at every point. And everywhere along that line has the same potential energy. We could then draw another equipotential here, like this. And everywhere along here also has the same potential energy. There are a few neat rules about equipotentials. The first is, because every place along the line has the same potential energy, if you move along an equipotential, you don't have to do any work. It's free, because you're not moving through the field. So as long as you stay on an equipotential, you don't have to do any work. In exactly the same way as if you walk along a contour line along a hill, you'll stay at the same height. Secondly, they'll always meet field lines at 90 degrees. Which again would make sense because we know work done is equal to how far you move multiplied by the force multiplied by the cosine of the angle. Therefore, cos 90 being 0, we would expect those to be at 90 degrees to the field lines. But thirdly, I just wanted to show you how the negative thing works, because this is something that we really want to go over again and again. I'm just going to show you this once now in the term of equipotentials, but don't worry, we will come back to this. So gravitational potential energy is always negative and is 0 at infinity. This means as we move closer and closer to the mass, we'll get a bigger negative number. So this might be minus 50 joules equipotential, and this might be minus 100 joules. Now this isn't very difficult, but for some reason people always struggle with it. The way to think about it is if this is the line, minus infinity, 0, plus infinity, just a standard number line, whenever we move this way, we're gaining energy, and whenever we move this way, we're losing energy. So if we go from minus 100 to minus 50, well, we're moving that way up the line, therefore we're gaining energy, which is exactly what you'd expect. If you lift something up, if you move it away from the mass, it will gain potential energy. We move from the minus 100 to the minus 50, we're actually gaining energy. But the numbers sometimes make it look as though you're not, so you just got to be smart with that. Exactly the same way, if we go from the minus 50 to the minus 100, we're moving that way, we should be losing gravitational potential energy, which is exactly what we'd expect because we're falling, moving towards the mass. So that's what equipotential is. It's just a line of equal potential energy. And I just wanted to show you how the negative numbers work, because although this is just very kind of, GCSE number line stuff, it does trip people up. It's exactly the kind of thing that even I get the wrong way around all the time. So just be a little bit careful. If you're ever not sure, just draw yourself a little number line. No shame, much better to get the right answer. Okay, There's some questions underneath. I want you to email them to me by midnight on Friday. Remember to put your name on them, and I'll see you next week.